equations and inequalities. So before we were simplifying radicals, we graphed some square root functions. Now we're actually going to solve radical equations. So a radical equation includes radical expressions. You can solve a radical equation by raising each side of the equation to a power. Okay, so you want to raise it to a power to cancel out the radical. So you have a couple steps here. Step 1 is to isolate the radical on one side of the equation. So whatever's in your radical, you want to just isolate that on one side. Step 2, raise each side of that equation to a power equal to the index of the radical to eliminate the radical. So if I have a fourth root, you would raise that to the fourth power to eliminate it. Okay, so whatever your index is right here, that's the power you raise it to. Okay, and then step 3, solving the resulting polynomial equation and then checking your results. You do need to check your results. Okay, sometimes you can get no solution. Okay, so you have to plug that number back in to see if it works. So when solving radical equations, the result may be a number that does not satisfy the original equation. Such a number is called an extraneous solution. Okay, so we do have these extraneous solutions. So we are going to solve some of these equations. So letter A here, my first step is to isolate the radical. So I want to get just this square root of x minus 2 by itself. So to do that, I would add 1 to both sides of the equation. So I end up with 6 is equal to the square root of x minus 2. So now I've isolated that radical. Okay, since this is a square root, next I'm going to raise it to a power. It's a square root, so I'm going to raise it to the power of 2 to cancel out that root. Now whatever I do to one side, I have to do to the other side of my equation. So I would raise that 6 to the power of 2 as well. Okay, so on the right, my root and power cancel. So 6 squared is 36. And that'll just be equal to x minus 2. Okay, then just getting x by itself, solving your equation from here, I'd add 2 to both sides to get x is equal to 38. Now you do need to check your answer. Okay, so I do need to check that answer. I need to plug in 38 for x. So I would have 5 is equal to the square root of 38 minus 2, and then minus 1. So 5 equals the square root of 36 minus 1. Square root of 36 is 6. So I do end up with 5 is equal to 5. So that does work. So then I can circle my answer or box my answer. Okay, do not box or circle your answer until you check. Okay, that's not always true. I thought you were going to throw that at me. Okay, questions on that first example there? Not so bad, right? All right, so I have another type of example here. I have 2 radicals, right? I can't really isolate anything further. Okay, I already have one of them isolated. So what I'm going to do is just raise both sides to that power of 2 right away. Okay, so I'm going to cancel out this radical first. Okay, since it's a square root, I raise it to the power of 2. On the left here, those will cancel each other out. So I have x plus 15. Now that's equal to this quantity squared. Okay, when I have that quantity squared, I'm taking that quantity and multiplying it by itself. Okay, so you do need to FOIL that. Okay, you have to FOIL that out. That's why I wrote it like this. So I still have x plus 15 on the left. Here I'll multiply my first term, so 5 times 5, 25. 5 times the square root of x is just 5 square root of x. Again, inner terms, 5 times the square root of x. And then square root of x times square root of x, what do I get when I multiply those? It would just be x. Okay, so I would have the square root of x squared. Okay, those would cancel, so I would just have x there. All right, so I'm going to combine like terms. So I have x plus 15 is equal to 25 plus 10 square root of x plus x. Okay, next, we're just going to continue combining terms. So I'm going to subtract x from both sides. What happens? They cancel on both sides. So I have 15 is equal to 25 plus 10 times the square root of x. Now, I'm going to solve this like I solved this one over here. I want to isolate that radical. Okay, I want to get that radical by itself. So I'm going to subtract 25 from both sides of my equation. So I have negative 10 is equal to 10 times the square root of x. Again, I need to isolate that radical. So I'm going to divide both sides by 10. So I have negative 1 is equal to the square root of x. So now that I've isolated that radical, I can raise it to the power. And that power is 2 because it's a square root. So that root and that power cancel. Negative 1 squared is 1. And that will be equal to x. Now again, before you circle or box your answer, you do need to check that it works. Okay, so here you need to check. So here's my root. So I have 1 plus 15 equals 5 plus the square root of 1. Okay, so I have the square root of 16 is equal to 5 plus 1. Square root of 16 is 4, equal to 6. Is that true? No. So this one is an extraneous solution. Okay, so we don't have a solution. So that's why I don't want you to circle or box x is equal to 1 right away. You need to check to make sure it works because this one did not. Okay, question solving, letter B. Did you follow me as I went through that? Maybe if you weren't on your phone when I started, you were. All right, then on Monday we went over rational exponents. That's when you have that fraction as an exponent. We did more work with that yesterday as well. So we can still solve these equations similar to what we were just doing above. So when we have an example like this is still radical. So we do want to just isolate this parenthesis here, so that quantity to the 1/3 power. Okay, I want to isolate that. So first I'm going to add 4 to both sides of my equation. So I have 2 times the quantity x, or 6x minus 3 to the 1/3 power is equal to 4. Now if I'm isolating that quantity, what should I do next? Divide by 2. Okay, so I have 6x minus 3 to the 1/3 power is equal to 2. So now that I've isolated that rational exponent, I want to make that exponent 1. Okay, what would I have to multiply 1/3 by to make it 1? 3. Okay, 3 times 1/3 would be 3/3. That is 1. So whatever I do to one side, I have to do to the other. So here my fractional exponent and my power cancel each other out. So I have 6x minus 3. And then I have 2 cubed. What's 2 cubed?
8,654.
8,654.
It's 8. Okay, from here all I have to do is solve for x then. So add 3 to both sides and divide by 6.
Wow.
And yes, I'm going to leave it as 11/6.
I would too.
Okay, again, you need to check. Okay, so I'm going to check this answer. Plug it into my original. Okay, so I have 2 times 6 times 11/6 minus 3 to the 1/3 minus 4 has to equal 0. Okay, I keep it as a fraction because look what happens right here. When I multiply these, my 6's cancel. So I have 2 times the quantity 11 minus 3 to the 1/3 minus 4 equals 0. Okay, so all I did was cancel out my 6's. So 11 minus 3 is 8. Okay, what's 8 to the 1/3 power? What's the cube root of 8? 2. I know you know what it is.
0 equals 0. True.
Yes, 0 will equal 0. That is true. So this would be my answer. Okay, questions on example 2 with your rational exponent. Okay, we're just solving for the variables. All right, then I want you guys to try example 3 at the top there. Solve for m. So isolate your radical. Step 1, isolate your radical. Step 2, raise it to a power. And then step 3, finish solving algebraically for that variable. Are we good on this side? Okay, so you should be doing example 3.
We're working on some little sheets. Yeah.
Yep.
Do you raise it to the 6 right away, or do you add 4?
You add 4 like
And
this.
then you raise it to the 6?
No.
Then divide by 7?
Yes. And then
Where do you get this?
And it doesn't open and it twitches. And I just push your glasses, but I don't know. I found it. I was done. Software. And they're annoying. When you get glasses. I feel like I don't want to type because you're putting out here. So you're in your head. You say so. Make it weird. You realize we all have it's so heavy right here. My face is so heavy. You say so. I still get homework too. There's stuff I have to do. No. And it's not making this I have to work. 4. 6. I don't want to put a note or say. And then I failed it.
I do
Did you see Jocelyn the other day? Oh yeah, she sent it to me.
At first I got confused on what she said. Oh, yeah,
I know, she didn't realize that going to the bathroom and watching the phone. All right, so most people got to hear, at least.
No, I got further than that.
Good job.
Thank you.
So once I get to this step, okay, I isolated my radical. I need to raise it to a power that is my index. Your index is this 6 right here. So I need to raise this to the 6th power. Okay, I have to do that to both sides of my equation. So that 6th power and this 6th root cancel each other out. So then I have 5m plus 4 is equal to 64. Okay, then I just need to subtract 4. So I have 5m equals 60. Divide by 5. To get m is 12. Now again, you do need to check this to make sure it works. Okay, so to check, we have 7 times the 6th root of 5 times 12 plus 4. Hey. Minus 4 equals 10. Okay, so 7 times the 6th root of 60 plus 4 minus 4 equals 10. So we have the 6th root of 64. Okay, the 6th root of 64 is 2. So we have 14 minus 4 is 10, which is 10 is equal to 10. So that is true. So m does equal 12.
I didn't even do that.
Oh, yeah.
Okay, and I just showed them.
You should check it.
But
It's
I
not
knew.
always right.
No, but I knew it.
Oh. All right, questions on example 3.
Yeah.
Yeah?
No.
Okay. All right, then we also have radical inequalities. We're going to solve them pretty much exactly the same. Okay, you just have an inequality symbol. So radical inequality has a variable in the radicand. To solve radical inequalities, you complete the following steps. So step 1, if the index of the root is even, identify the values of the variable for which the radicand is non-negative. Okay, you have a domain error with these ones. You need to make sure you're checking that. Step 2, solve the inequality algebraically. Step 3, test the values to check your solution. Okay, so we have our different steps here. So in example 4, letter A. Example 4, letter A. This is a square root. My root is even. I need to check what's inside my radical here. So that quantity, 3x minus 6, has to be greater than or equal to 0, just like we did when we were finding the domain. So when you're solving radical inequalities, you need to check that domain as well. Okay, greater than or equal to 0, just like when we had the domain. So from here, I'm just going to solve for x. So I'll add 6. So we have 3x is greater than or equal to 6. Divide by 3. So x has to be greater than or equal to 2. So now that I've found that domain, next I can solve my radical inequality just like we did on the front. So first step is to isolate your radical. So you need to subtract 4 from both sides. So I have the square root of 3x minus 6 is less than or equal to 3. I'm going to fix my paper here. Okay, what should I do next? Now that I've isolated that radical. What should I do next? Square both sides. Okay, it's a square root, so I raise it to a power of 2. Okay, that way that power and my root cancel. So I have 3x minus 6 is less than or equal to 9. And from here I just solve algebraically for x. So add 6. And divide by 3. Okay, so now as my answer, what I have is x has to be greater than or equal to 2, and x has to be less than or equal to 5. Now what I'm going to do to check this solution is actually draw in a number line and plot each of those values. So I have a 2 and a 5. Okay, so I have 2 here, 5 here. Now with the 2, my x values have to be greater than or equal to that 2. Okay, so if it's greater than or equal to, that's a closed circle. And which direction should my arrow go if they have to be greater? To the right.
All I gotta worry about arrows.
Okay, then my second solution here was x is less than or equal to 5. So at 5, again, I have a closed dot because it's equal to. And now I need all the values that are less than that. So that one will go to the left. So you have to see where these two overlap to get your answer. Okay, so these two overlap in the middle right here. Okay, so meaning my answer should read x has to be greater than or equal to 2 and less than or equal to 5. Okay, so if you overlap like that, you always write your lowest one first, highest one last here. Make sense? Kind of? Questions on letter A? That is your check. So your check is the number line. Okay, then we're going to do letter B. So again, this is a square root. So you need to check the domain first. So whatever is underneath your radical has to be greater than or equal to 0. Okay, so 2x plus 2, greater than or equal to 0. Solve for x. Okay, divide by 2. So x has to be greater than or equal to -1. So after I find that domain, next I can solve my inequality. Okay, so isolate your radical. So subtract 1 from both sides. So we have the square root of 2x plus 2 is greater than or equal to 4. Okay, what power do I raise this to? 2 or the second power, yep. I have to do that on both sides so that I can cancel out my root and that power. So I have 2x plus 2 is greater than or equal to 16. Okay, subtract 2 from both sides. And then divide by 2. Okay, so again, with these ones, you do get those two separate inequalities here. So you check it using that number line. Okay, so here I have my number line. I plot the two numbers that I got. So I have -1 and 7. So for -1, my x values have to be greater than or equal to -1. Okay, so it's equal, so I've closed that. They have to be greater than that. So that'll go to the right. For my second one, I have x values greater than or equal to 7. So again, closed. And since they're greater than 7, again, that goes to the right. Okay, so my overlap here is just right here, right? And it'll keep going on and on and on. So then my only answer would just be x is greater than or equal to 7. Okay, so that's why we check using that number line. So just because you had this domain here doesn't mean it always ends up in between the two. Okay, it could just end up this way. It could end up where you have no solution. Okay, so if you have, they don't overlap at all, that's no solution. Okay, make sense? Questions?